All right, so good morning, everyone. I hope you're all doing well. So, like Dr. Mills rightly said, today we are going to focus a lot more on the random generation of data, and it's going to be an interesting one. So let's quickly, let me share my screen, and then we'll make progress. Okay, so I'm going to activate my Jupyter Notebook environment in here. Now, what I want to start off with is something we couldn't touch on Tuesday. So quickly, I want us to clear that part so that we can.
Please, sorry, I said we were going to call somebody, one or two people randomly to show us what they did. I'm sure maybe that was why some people were afraid to join. But uh, is somebody ready to share what he or she did? If you are ready, let's see your hand. Or you want us to give you the weekend so that you do it? Nobody is talking.
Hello, Doc.
Yes, please.
Yes, please. Can you kindly give us the weekend so that we do it?
Yeah, okay. So we will continue on then. But my interest is that not that we are just wasting our time talking, because I would have just diverted my research funds to do something else. But what we want is to make sure that you are following what we are doing. If there is a problem somewhere, you draw our attention, then we help you. This is the essence of, if you are doing something on just virtual something, you will never get this anywhere. So please, when we ask something, those who will be interested, you do it and then you bring us feedback. If it's not correct, we'll help you to, at least so that you make progress. So we'll finish with what we are doing today, and then we'll let you also pick your own data set and do what we have done so far. So Ken, please go ahead.
All right, sir. So last Tuesday we covered everything, and we were left with this part where I'll be talking about filtering, sorting, and a very important concept over here, data correlation. So what I'm going to do is I'm going to run all the cells so that everything works. So because this is the first time I'm running this today, it may take a while, but then just about now, everything is okay. So now let's look at the filtering. We have our original data sets. We've dropped the duplicates. We've done a number of things over here. So if I'm to do a preview of the data, everything looks good. We have 154 rows by 6 columns. So now let's look at how we can do some filtering. And basically, filtering is exactly what it is. We want to filter. We want to, for instance, out of the lot, select or filter based on a particular criteria. So the way we go about that is very simple. We can use the objects, which is the data. No, sorry. Let me see. Yeah. So data dot. Let me check. Okay, so data dot filter this way. And now there are some parameters that we can pass here. So the question is, what do you want to filter by? So for instance, we can say, okay, I want to filter by, let's say, the sepal length. So I'll do this to copy the sepal length CM, and I'm going to say like, and I'll pass sepal length over here. So when I run this, I have says whatever thing is not available. Okay. Let me just quickly do this. Let me open this up here. So let me see. Is equal to PD dots. I just want to have the benefit of how do you call it, intelligence to get some help over here. So this morning I was working with the random data set that we'll be generating for some fruits, and we are going to see how we go about that. But then I just want to have this, and now if I'm to do the filter method over here, this is what I want to see. So okay, so we have the like, and we need to pass in a string and not a list like I was trying to do. So it says keeps labels from others for which like in label is equal to true. And then we can filter by a number of parameters. So as you can see, we can filter by the items. We can filter by like, then we can also have a regular expression, and also by the others. So let's do the like over here. So if I put in like is equal to, and this is supposed to be a string and not a list. So let's say I want to filter, and this time around, the like, it can be, let's say, a full filter or like a partial filter. So if I say I want to filter data.filter, so anything within this pandas data frame that has something like sepal, I just want you to filter out for me. So clearly, we are going to see that it is only going to be the sepal length CM and also the sepal width CM that has some element of sepal within the names. Okay, so when I do this and run this, that's exactly what you see over here. So it can be just SE. It will just look through anything that has anything resembling SE to just filter it for us. Then if I just want to, let's say, filter by, let's say, the word width. If I select the word width and filter by the word width over here, then anything that has width in there. So in this particular case, it is going to be sepal width CM because it has width in there, and then the petal width CM. So this is a little bit dynamic. We just want to filter by something. So this is the like. So filter by something that looks like width, and that's what we are getting over here. Now let's look at the other one, which I was talking about, which has to do with the item. So now if I'm to do data, yes, data is going to be the whole thing. I've not done any filtering over here, but then I also want to do a filter. And now I'm going to use the item. I think it is supposed to be items, I believe. Let me see. Yeah, items. And there's going to be a list like filter. All right. So the items, and then we pass in what do you want to filter by. So let's say I want to filter by just the sepal length CM. Okay. So now it's just giving me sepal length CM. But then because there's a list, I can add in other parameters. So let's say sepal length CM and maybe the species. So this one gives me that flexibility in my filtering. So I want to filter by this and the species. So I pass in this over here. And then when I run this, I see that everything from that column, sepal length, is showing, as well as everything from that corresponding column from the species column is also showing up over here. And then I can also add more, provided the column names are over here. So maybe I want to do petal length here. And the order in which you put them over here in terms of your filtering items is going to be exactly how it is going to show up. So when I do this, clearly I had sepal length first, and that's what I see over here. I had species second, and species is what I see over here. And then I had petal length CM10, and that's exactly what we have over here. So this can be a very good thing just for you to, let's say you have a large chunk of data set with a lot of columns. You just want to filter and have a quick preview of some things. This is what you can do. But then we already know that doing this way does not override the data, because when we do data, it's still going to give us back the original data. So what we said last Tuesday was to, let's say, give this some kind of a new variable name. So we'll do the filtering over here, and then we'll save it in this new variable. So now everything looks good. So if I'm to do a preview of this, I get this. And then we can go on and on. So for instance, after doing this filtering, we can do some of the things we used to do with our data set. So for instance, I can do this filtered data.info just to get that statistical inference from that particular subset of filtering that I've done. And that's exactly what we have over here. We can do the .describe to also get whatever thing describe, whatever thing that we want. So everything is looking good so far. Now let's look at the sorting, because the sorting is actually going to help us very much. Okay, so yes, these are original data sets and I want to sort. So if you want to sort something, definitely you are sorting based on some metric or some parameter. And hello, please, can you hear me?
Yes.
Okay, sorry, I think my line dropped. I'm using my phone as the hotspot and somebody just called, so sorry about that. So we are going to do the sorting, and the sorting is definitely going to be by some particular metric or some parameter. Now, by default, the way the data is presented is how it's going to be sorted. So in this particular instance, the sorting is by the IDs, okay? The sorting is by the IDs. So let's say I want to sort by the sepal length CM. So now I can do data dot sort this way. Now, when I do data dot sort, I need to specify by which whatever I want to sort with. So now let me get a little bit help over here. So when I do data dot sort over here and hover my mouse around sort, okay. Okay, it's saying sort values. Okay, so the first one it takes is a strange, or it can take a sequence actually, and then the others, and then the kind of sorts, and some few other things over here. Okay, so yes, so we want to sort by either a strange or by a sequence, which can be a list. And then we can look at it in ascending order or descending order. And when we do the in place is equal to true, like we saw on Tuesday, it is definitely going to override that particular or original data. So let me see, sort values by, okay. So let me do sort underscore values. Then I'm going to say by. So this time around, I want to sort by the sepal length CM. Yeah. So if I run this, now the sorting is done, and I want you to pay particular attention to what is happening over here. Now, previously, this original data set, you could see that the IDs start counting from 1 to, to the last one we have over here. Now, after doing the sorting and sorting by this sepal length CM, is by default going to sort in ascending order. So it's going to look at the values we have in sepal length CM. It's going to sort them for us. So based on that sorting, you can see that it is automatically affecting its corresponding let's say, values on the other end. So for instance, with the ID, because we sorted and based on what exists in the data sets, the 14th row has the least value. So definitely that's what is going to show up this way. And this is what I say we can use to actually check for, let's say, outliers. So for instance, we know that the least value is about 4.3. And imagine we are seeing 790 instead of 7.9. Then clearly that should click that, well, probably something is wrong over here. So definitely the outlier is going to be a very big value out of the norm. And because we are sorting in ascending order, it is definitely going to be the last one that we are going to see over here. And if we are to compare, for instance, maybe the last value with its preceding ones, we can make sense out of it and say that no, this cannot be the case where we are starting from 4.3 and then ending at maybe 7,900. That does not make sense in a lot of ways. But then for some data sets, it could be. So that's why Dr. Mill said, definitely when we are working with the subject matter experts, you get a lot of insights on those things. So that's with the sorting. And you can sort by any of the other parameters over here. So if I'm to sort by, for instance, the petal width CM, let me do that quickly and run this. It is now sorting by the petal width CM. So clearly the least value over here was 0.1 and then largest value was 2.5. So it is also sorting and matching up with the other ones. Okay, so now let's look at the last one, then we'll quickly jump into what we are supposed to cover today. So yes, we still have our original data set, and then we want to get some analysis where we are going to look at correlation. So correlation is very important for most of the things that we'll be doing. So in order to do this, I can simply do data dots, and this one is core, C-O-R-R, this way. So when I do this and run this, okay, so obviously we are getting some issue. It says it could not convert the string, okay, to float. And those were, for instance, the, how do you call it? These ones that we see over here, okay? So definitely correlation is sorting or like finding the relationship between values, okay? Either integers or floats, but then we are having some strings that were not making sense to our system. So what we can do is we can definitely get rid of this species column. And there are a lot of ways we can do that. So for instance, a very long way will probably be to do some sorting over here. So we can do the, some filtering over here. So we can do data.filter and we pass in the items, everything except for the species column. So that's one way of doing it. So let me simply do that or quickly do that. So I'm going to do dot filter this way. And then the items that I want to filter by is going to be the list of everything except the species. And like I said, that's a very long way of doing this. But then let's look at it first of all. So I'll do this comma, and then I'll bring the sepal width CM, after which I'm going to show you a very simple way. Then the petal length CM, and then this one. So definitely that filtering has taken place. So let me save it in a variable called, let's say, X. So now I have X over here, and X is just the sepal length, sepal width, just as I've stated out over here. Now I can do X.core, which I'm definitely going to get the correlation that I want over here. Now I'm going to explain briefly what we have over here so that we can make sense of whatever thing is happening. But then the other thing that we can do, instead of going this long, is rather look at this objectively. So we have these things over here, and I just want to get rid of this. So maybe it is not a matter of selecting the others, but then just dropping this. So I can actually drop this. So let's go back to the original data frame, which is data as we have it over here, okay, with species added. Now, when I do dots, there's a drop method in here. So now the question is, okay, what do I want to drop? Okay, so I want to drop a particular column. So now I specify the columns, and then the name of the column over here is going to be species. So I'll do a Control-C of this and then run this. So now when I run this, clearly you can see that now species is gone. So instead of doing the filtering and selecting 5, I'm just dropping 1. So certainly everything looks good now. Now let me save it in a variable called y. And then finally, I can have a preview of my y. Everything looks good. Now I can proceed to do the y.core to get the correlation as I have it over here. Okay, so now let me spend time to go through this. I think even with this one, the IDs are not giving us any value in terms of whatever thing we need, but then it doesn't spoil anything. Now, when we are looking at correlation, we are looking at the relationship between dependent and independent variables. Okay, so at one point we hold, for instance, sepal length, sepal width, petal length, petal width, all as dependent variables, and we hold these ones as independent, then we flip it. Okay. Now, what you see is normally at the main diagonals, we are going to have 1, 1, 1, 1, 1. So correlation is going to be between any number between a very large negative number, okay, and then 1 is the highest. So the closer you are to 1, then that means that data is correlated in a way. Now, correlation basically means if you have a positive 1, okay, so that means between ID and ID, when this one rises in our data set. And when this one falls. So that's like that positive correlation. Now, between, for instance, sepal length and sepal length, I mean, it is going to be 1 because it is the same value. So if it is 1, it is 1. If it is 2, it's 2. So they all move together. But then what we can actually critically look at is, for instance, the sepal length and, for instance, the petal length. And the correlation over here is a 0.86 approximately. So over here, there's a very high positive correlation, which is quite closer to 1. So what it means is, in this particular data set that we are doing this preview of, when the sepal length of any particular species increase, the corresponding petal length also increase. In the case of the negative correlations that we see over here, for instance, maybe this particular one, which has to do with the sepal width against the petal length, what it means is, for any particular data point that we pick, if the sepal length increase, the petal length decreases. So they are moving in opposite direction, kind of, yeah. And that's a brief description of correlation. Later on, we are going to go deeper into some of these things. So we are going to understand them even better. Okay, so we are done with this.
Ken, can I have 1 minute for me?
Oh, no problem,
Right.
sir.
So just keep what you see, the third year students, you are doing statistics, or you did statistics for engineers. And some of the techniques that you use are applicable in this aspect of data correlation and analysis. So whatever you are doing, don't take it that you are learning just for marks and go away. But if you have to employ a machine learning solution, then your knowledge in the statistics for the data here will be very important. For those who are in the lower levels, at least you did some basics in senior high school. So when if you don't understand, you let us know. But at least when you get to third year, you'll be taught statistics for engineers and some of the deeper ones that you need to know. For example, the correlation, the t-statistics, the chi-s, all those sort of things. You'll be learning on those things to help you get a better correlation or relationship in your data, to know what is making sense, what doesn't make sense. And we also link this to what we call feature relevance You look at your features, which of them play very relevant role in your model prediction. Okay, so thank you about that.
Okay, thank you very much, Dr. Mills. So quickly now, let's move to before okay, let's do that one. So let's move to working on generating our own data sets. Okay. Now, before we do that, let me quickly come back here and introduce you to something that's going to help us go about the data set generation. So yes, I'm in my VS Code environment. I just open, let me close these ones. And what I'm going to do is I'm going to introduce you to a module, okay? And this module is going to help us do some interesting things that's going to help us generate those random data sets. And I've kept on saying random, random, random. Yes, they are random. So if we leave it to be random, it's going to be random, but then we can put in some parameters or some checks so that even though it is random, but maybe it is within a specific range. So yes, we might want to generate random data, but then we are mindful of the fact that it is not any random number that will make sense to us. So we are going to see that. Now, the module that we are going to learn is the random module. So there's an inbuilt module inside of Python called random. And just as we've dealt with some few inbuilt modules, for instance, when we're dealing with some mathematical operations, we looked at the math module. Okay, so we saw something like import math, and we started working with math. All right. So over here too, we are going to import random, and this random module is going to give us the opportunity to randomly do certain things. So now the first task is, okay, let's say if I want to generate, let's say, some random data, okay, like a random number, basically, then there are some things I can do. So let's say I have, let me call this generate random number. And this number, first of all, we are going to generate a random floating number. Okay, so this number is going to be a float. So I can do random because I've imported it over here, dot random. So random.random, and then I'll call it up this way. So clearly you can see that this is telling me or giving me an indication that this is going to generate a floating point number. Now let me save this in a variable called, let's say, data. So data is going to be equal to random.random. I'm generating some random number and I'm saving it in a variable called data. Now let's do a preview or a printing of that data and see what it actually looks like. Remember I said it's going to be a floating point number. So now when I run this, we get this floating point number over here. So we get a 0.78, blah, 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 okay? I can run this a number of times, and each time I run it, it's going to randomly generate some floating point number. There's another one it has. Now, the key thing is when we do or we use the random, okay, inside of the random module, this one is going to generate a floating point number between 0 and then 1. So when I say between 0 and 1, over here, 1 is not inclusive because 1 is not a floating point number. So it is definitely going to be, the actual numbers are going to be like 0.00000 whatever to, for instance, maybe 0.99999 whatever. Okay, so any number between this. And you could clearly see that based on the generations that we have over here, if you pay close attention to the numbers that we see over here, the first one that was generated, if I can count and not even waste my time so much, you could see that these ones were, in terms of the bit size, was a little bit long. I mean, this one was longer than this, okay? So it is quite random, but then hello, please, can you hear me?
Yes, you paused for a while, but we can hear you now.
Okay, all right, sorry. I mean, another call came through, that's why. So Yeah, so this is the random numbers, and we can kind of regulate things a little bit, okay, in a sense that yes, maybe we want random numbers to 2 decimal places to 4 decimal places. We know what to do, okay, and we can put this in a round function. And when we do round, then we specify the decimal point. So for instance, if we want just 3 decimal places, we can do, this is by default going to generate that random number between 0 and 1, and then it is going to have just 3 decimal places. So now when I do this, we get to see this, okay? So at least we are putting some restrictions to the number of decimal places over here, but at the end of the day, it is still going to be a random number. So this is just one way of looking at it. Then somebody may ask, okay, what if I want to generate, for instance, a random number, which is a float, but beyond 0 and 1, okay? So I want to have some kind of flexibility. Now, what then we need to do is, let me also once again comment this one out. Then that one is going to be random dots. Then we use another method in there or another function in there called uniform. So this uniform, we need to specify a range, okay? So it says get a random number in a range where we are going to put up the starting number and also the ending depending on the rounding. So over here, it is going to return a float. So this one also returns a float. So let's say I want a number between 1 and then 20. So any floating random number between 1 and 20, and there are going to be a lot of them. So when I do data is equal to this, and now do a printing of data. When I run this, yeah, this is giving me a random number between the range I specified over here, 1 and 20. So this random float number is between that range, okay? I can run it again and it's going to give me different numbers as I move on. Now, this is also good because we can, for instance, do a negative 20 and a positive 20. So this expanding the range for us. And now when I run this, currently we are getting positive numbers, but I believe, yes, now we have a negative random number showing up over here. So the flexibility this one also gives us is looking good. So this is going to be a random number. And once again, if we want to have it to 2 decimal places, we just have to wrap it in the round function and specify the number of decimal places that we want. Okay. So now let's look at this. And now the question is, okay, what about if I want a random integer number? So if I want a random integer number, then once again, yes, we are going to fall on random dot. And then there's one over here called rand int. So I think the name is quite intuitive over here. It is going to give you a random integer number. So over here too, we need to specify the range. So over here, the starting range and the ending range. So let's say I want to start from 10 and then end at, let's say 30. Okay, this is going to be just 20 numbers in between. So over here, data is going to be equal to this. And if I'm to do a printing of data, obviously random numbers or random integer numbers between this and that. Okay. So this one is giving us some flexibility and restriction. And we need to know this because moving on to generating random numbers, for instance, some numbers for some values can be negative. Okay. So if it is random data that I want to generate for ages, then ages cannot be negative. Somebody's weight cannot be negative. But then if it is about temperature can be negative. So we put all those measures in place. All right. So these are some of the things that we should know moving on to generating proper, how do you call it, data. So now let's look at the other one, which is going to be an interesting one. So let's say we have a variable called features, okay? And features is going to be a list. So,
Ken, sorry, can I pause you a minute?
oh, no problem.
Can you please go back to, let us see that anytime you generate the number keeps changing.
Yeah,
so
sure.
Can we explain to them how we can get a seed to fix the number?
Oh, okay. All right, sure.
So that at least if you want to maintain the same consistency in the same number.
Yeah. Okay, so we can get a seed to fix a number because, like Dr. Mills rightly said, let me just show you. Sorry. When we do this, let's say between 1 and 10. Anytime you run this, it is going to change, okay? So the numbers are, they keep changing over here. And this may not be desirable if, let's say, our code is going to run and we generate data and later on things are changing. So we can put in a seed. So over here, we can have, let's say, instead of random.randInt, let me say I have data is equal to, let me comment this one out. We can say random dots, and then there's a seed method over here. So over here, we can, of course, get some information over here. So it says over here, then we want to initialize a state from a seed, okay? Now, the only supported seed type are none, okay? Int, float. You can also look at string, byte, and byte array. Now, none or no argument seed for current time or blah, 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 okay? And now, there are a lot of things that we can learn from this. So we can put in a seed value over here. So let's say our seed value is 10. Now see what's going to happen. And if I'm to do a printing of, let's say, data as we have it over here, we get none showing up. And anytime we do this, we get none. Now, if, let me see. Okay, this is always going to return none and initializes. Okay. So let's say I do data dots. Okay, this is a none, so I don't have those methods over here. So let me do X is going to be equal to random dots, let's say randInt, and passing the data. Let me do a printing of X to see what we get. Okay. Okay, it is expecting okay, so let me do data once again. So the starting and the ending, and then it says, oh. Okay, there's also something that we can do, which fix this. Hello. Hello.
Hello, sir.
All right, okay. So then let's check again. So there's something that we can do, which we are going to come back to, and that's going to be that's going to explain something I want to do. But then let's just hold on for now. We are going to come back to this seed and how we can hold on to numbers and see how they work. So let's just go back to what was I even talking about? Yeah, we are going to talk about, let's say, features. Okay. So features is going to be a list of features. So let's say we have age, and then let's say we have height, maybe we have weight, and then let's say complexion. Now we can randomly pick any of these. Okay, so let's say for instance, maybe these were like some values representing age, weight, complexion, and we just want to randomly select one of them. Now the randInt is not going to help us do this because this is not an integer. Okay, this is a list. The uniform and the other ones are not going to help us. So we can use the choice method in there. So I can say random.choice. So there are two. There are choices and there are choice. We are going to see all of them. But then let's start with choice. So when I do random.choice and also hover my mouse around this, it says it chooses a random element from a non-type sequence. So the non-type sequence is what we have as this list. So when I put in features and do a preview or a printing of data over here and run this, now upon running it the first time, it randomly picks age for me. When I run it again, it is picking weight. When I run it again, it is picking age again. Now picking height, age, and it goes on and on with other things. Okay, so we get to see this. Now we can also look at the choices. Now the choices is going to give us some flexibility. So let's say the choice is just helping us picking one, and the choices by its intuitive definition is going to help us pick maybe a couple more. Okay, so if I'm to do random dot choices, okay, and put in features over here. Now, politically, it is just picking one, but then we can specify the number of items that we want. So clearly, you can see that now it is not just picking an element, but it is picking like from a list. Okay, so you can populate this list by the number of elements that we have. So now when I hover my mouse around this, we see that I have this parameter k, and this k is going to be an integer. Okay, and what does this k mean? This k is actually the size. Okay, so returns a key size list of population element chosen with replacement. So if I'm to do comma a key is equal to, let's say, 3, then what I'm trying to say is, okay, out of this features list, which has 4 elements, randomly choose things over here, but then the size should be 3. So now when I run this, I get randomly selected, and over here it can repeat. So it is repeating weight, and then it selected height. Okay, we are going to see an instance where we don't want to repeat. So now it is also selecting age, and then weight again. Now when I run this once again, now this time around there's no repeats. Okay, so this is just with the choices. Now there's also another one called sample, and now this sample is not going to do a repeat. So over here to sample, it takes a population, which is the list that we pass over here, and then the k, which is the size. Okay, and over here with the sample, it says that chooses k unique random elements from a population. So it is going to be random, but it's going to be unique. So there's not going to be a repetition as we saw with the first one. So now when I do this and run this, now we get, yes, some random selection based on the key size of 3, but then everything over here is going to be unique. So there's not going to be an instance where we have weight, comma, age, like we saw previously. So it's going to be unique throughout. So those are the differences. And it depends on exactly what you want to do. There are some instances you don't want to have data repeating. There are some instances it can repeat. I mean, 2 different people can have the same age. So those repetitions are possible in some instances. But then maybe if it is maybe some, let's say, index number random data that you want to generate, then no 2 people can have the same index number. So you be mindful and go with a sample method over there. So that's just it. Now let me just do a little bit more of these features, because there's something interesting that I didn't mention. So let's say I have features, more features over here. So let's say I have, let's say something like income, something like savings. I mean, some random data that maybe somebody is going for a loan at the bank and they need to check all these things. So for instance, they pick some bio data, your age, your weight, maybe complexion, and then your income and your savings. All right. So this one is looking good. It is still going to select unique because you are using the sample over here, okay, from the list as we have over here. But then let's go back to the choices. Now, I'm going to do something interesting over here, because when we are selecting, and this one, in order for this to make sense, we need a very large list, okay? We need a very large list so that we can have different permutations of selections that we can do. So in order to get that, let me just do it this way. Let me have data is going to be equal to let's use a range, the range method. Okay, so within range, let's say we are starting from 1 and ending at, let's say, 50. And if I'm to do a printing of data as I currently have it, then certainly it is not going to give me what I want, okay? It is just printing this as I have it for me, but then I want to do a typecast of this into a list. Remember, normally when you are using the range, or most of the times you have used range, it is we looping through something. And so for X in range, then that one will work. So if I do a typecast of this into a list, then technically that looping will be done, and oh, what's up? Good. That looping will be done and it will be saved inside as a list before it is passed in data. So now when I run this, I get that range showing up over here of the range I've specified. Good. So now this is what the choices that I want to have is going to make sense. Or I should go back to, let me rather go back to the names I have over here, because I want to accomplish a particular objective, and I think this one is going to help me other than this. So let's say we have this, and let's say our K is going to be 5. Okay, so because our K is going to be 5, let's have this a number of times. So please, I need more features. So let's say I have name. What else can I have? I have, let's say, location. I have a number of things over here. All right. So I want to select 5, but then to be more specific, I want to apply some weight over here. And the weight that I want to apply is such that, let's say if I put 10 over here, I just want this to be selected 10 times, okay? And okay, it doesn't really matter. Let me just make it very simple. So these ones. So the features has 3 features over here. I want to randomly select these choices, okay, 10 times, or the size of 10. So you're just going to select these ones randomly. And over here, you can see that there are repetitions of it, and it is quite random, okay? But I can apply weight to each and every element that I have over here. And of course, when I do a hover around this, we see the weight over here. And what I'm going to do is I'm going to say weight, and this weight is going to be a list. So based on the population that I have over here, it says if the relative weight or cumulative weights are not specified, the selections are made with equal probability. But then this time around, I don't want the selection to be made by equal probability. So look at what I'm going to do over here. I'm going to say 10, 10, 2. So this is what I say. I'm saying that, okay, for the number of times I want everything to be selected is going to be, at least the size is going to be 10. But out of this 10, I want to give a weight to, for instance, age to have a weight of 10, height to have a weight of 10, and then weight should have a weight of 2. So I'm not leaving it to chance for that random or arbitrary selection for me. I'm giving some weight. And later on, when we deal with the machine learning model development, we are going to come back to weight. And I have a very good example of how you should understand weight, but then don't worry, that one will come later. So this weight is basically just giving some kind of preferential treatment. Okay, so out of this, so when we sum these weights up, we get a total of 12. When we sum these weights up, we get a total of 12. Or let me do this as 5 so that I just want to do some simple calculation so that it becomes very simple. So we sum these weights up, we get a total of 25. Now, all I'm trying to say is, okay, so if you are selecting 10, which is my sample size, what I want to see is, okay, I want to have an instance where the number of times you select each is given a weight of 10 over 25 times the 10 over here. So the preferential treatment that age is going to have is going to look like this. It's going to be 10 over the entire sample space times this 10. Now, if you do the math, this is going to be like a 0.4. Let me be sure over here. So 10 divided by 25. Okay, then times 10. So we are getting a 4 over here. So at the end of the day, based on the distribution that I've done, I want, out of the 10, I want age to be selected 4 times. Then because height is also the same width as age, that one to 4 times, and definitely the width is going to be selected 2 times based on the specifications I've done over here. So now when I run this, we can actually do the counting. So let's start with width because that one is small. It's just 2 times. So you can clearly see that I have a number of weights over here. So I have 1, 2, and then 3 weights. Okay. And then the number of age I have over here is 1, 2, 3, 4, and then 5. And then we are shortchanging height. Height has 1 and then 2. Let me run this once again and see. Okay, now height is getting 1, 2, 3, 4, 5. And then width is getting 1 over here. And then age is getting whatever thing which is left. Now the point is, regardless of it being a little bit randomized, the most important thing is the one we give the least weight is never going to supersede in terms of its selection the ones that we give the higher weights as we have specified over here. So regardless of it being so random, it is not going to be the case. But then if we are to use the sample is actually one that's going to be like a very large list and we want to have a specific sample in there. Now, I think this is going to help us get to the basics of we generating random data. So now that we know a little bit about this random method, now let's move on to generating random data because we have about 30 minutes and I don't want to go beyond that. So we need to put things in context. And this is what Dr. Mills always say, that you cannot sit in your room and say you are generating random data. Yes, you can do that, but then you need to have some expert opinion, okay? And the reason I say that is we know that, for instance, maybe the normal human body temperature is maybe within a certain range, okay? And for maybe the normal range is like, I'm not too sure, but let's say 20 degrees to 30 degrees or something. I mean, I'm just picking up some random value. But then if you say you are generating random data for, let's say, human body temperature, and you are not an expert in the people who do these clinical trials, taking data all the time, maybe at the hospital, and you say, oh, because it is random data, you just want to have 200 degrees Celsius. Well, a human being 200 degrees Celsius is definitely going to be hotter than hot water. So that's not what you want. And it can also be an instance where the human body temperature is below some negative value, then probably that person is dead. So when that expert comes in, when that doctor comes in, when that clinical psychologist comes in, when that whatever expert comes in, that person is able to guide you. And that's why we are learning about, yes, random generation of data, but then we can put in some measures, some parameters to check. So what we are going to do is we are just going to do some assumptions over here, okay? And we are just going to assume we are the experts, we put in our parameters and we see how things works. But then the proper thing to do is to actually consult the subject matter experts. So over here, we want to generate some random data for fruits. And based on what I'm thinking, okay, we need to be thinking about, for instance, the features that we want the fruits to have. So there could be a number of features, but then I'm thinking about, and of course you can help me. And of course, let me just throw this out. What are you thinking when we talk about fruits? What are some of the features that you can think of?
The color of the fruit.
Okay, so somebody says the color of the fruits. And what else? Okay, somebody's also saying the size in the chat. Can we also look at the weight? Yes, we can. We can look at the weight. And okay, I have some answers in the chat. Okay, somebody says the shape. So the shape is going to lead us to, I think last year we were trying to figure out the shapes of fruit, and it was something else, because to say something is round has a technical meaning. To say something is spherical, to say something is oval, to say something is, a lot of things came up last year. Okay, so yes, we can look at the color, the size, the width, and we can go on. In fact, if probably we go to botany or people who are experts in fruit and maybe species of plant and stuff like that, they can probably give us about thousands of features that we can get from fruit. We can look at the texture, because every fruit has some texture. Because, for instance, the texture we feel around when we hold, let's say, pineapple, is different from the one that we get from banana. At least banana is quite smooth. Pineapple is very spiky, very rough. And even the one, for example, maybe we may get from orange. Okay, orange is rough, but not as spiky as we have a pineapple. So we can go on and on and on with different parameters. Now we can also look at, so it depends on basically what you want to build. Okay, if the problem is, for instance, maybe a fruit sorting system. Okay, so let's say we are looking at the bigger picture over here. We are going to build a system that we are going to deploy on some robotic engine, and that ML is supposed to, or that robot is supposed to capture the image of the fruit, and based on that image, it is able to sort, okay, there's mango, there's pineapple. So over there, you'll be looking at some of the physical features. But then if, for instance, maybe you've gone to the lab, these are samples, we are extracting, then maybe you can look at even the acidity, okay? Because most fruits, especially the citrus ones, are acidic. But then I'm sure there's some level of acid in, let's say, for instance, banana. I'm just guessing. But then the acidity in orange is definitely going to be more than banana. So as the acidity in, let's say, lime or lemon is going to be more than orange. And it even depends on, for instance, the age of the fruit, if I'm being politically correct over here. And let's say we can also look at something like maybe the sugar content. So we can go on and on. And these ones, sorry, sugar. And for instance, the sugar content and the acidity is not just going to be looked at like you just looking at it. I mean, you cannot come to a logical conclusion on that. That one, you just have to slice it and maybe squeeze some juice out of it to actually do the testing. So we can go on and on and on. But then let's make things a little bit simple for us. So let's look at and we forgot one thing. We also have to think about the name of the fruits, because each of these attributes is going to constitute to a particular name. So for instance, the color of the fruit. I've seen yellow, pineapple, some are green, but I haven't seen one that is, let's say, brown. Maybe, but then it is not too common. But then let's say if you are talking about pear, I've seen some colors of pear, not the pickup or the mesocarp or whatever. I'm talking about the fruits, okay? So we can also look at, for instance, the weight. And I think with the weight, we can look at, for instance, maybe average weight, and even look at a range. And then the shape, the texture, the acidity, and the sugar content. And that's going to give us a particular fruit. So let's say the color is, let's say, red, and the size is the size and the weight. See, so let's say the size is small. So S for small, and the weight is, let's say, 1.4 grams or whatever. I'm not too sure. And the shape is oval, and the texture is smooth. The acidity over here, and even with acidity, I don't even know what I'm talking about, whether it is pH or whatever. But then the subject matter expert will help us. So if it is pH, then we know that, okay, we are between a specific range, okay, 0 and 14. So below 0 is acidic.
Please, let's ask the biomedical and materials people. They should tell us.
Okay.
When we are doing this, let's ask them, the students, and they should give us what they think.
Yeah, sure. So with the fruit, when we look at acidity, is it going to be a measure of the pH? Maybe the food people can help us over here. We cannot be 100% right, but at least let's be a little bit intellectual about it. Should we look at it from the pH level? Are there no food engineers around? Okay. Okay, yes, somebody says pH. Okay, yes, we should. Okay. So definitely based on the little acid-based salts we learned in secondary school, which everybody did, regardless of being a food engineer or whatever. Yeah, so maybe because this is quite acidic, okay, so let's say we have something like, let's say, a 3.4, and the sugar content, what are you also thinking? Is there a way we can measure the sugar content? Okay, somebody has, I'm seeing bricks over here. What does it mean? The bricks, BRIX.
So the bricks is for the sugar content.
Okay. Wow. So we are all learning now. So we are seeing bricks over here. So this bricks now doesn't mean it is sweet or it is not sweet.
So it actually tells you the amount of sugar. It's not about the sweetness, but
Okay. So is there a measure, like, let's say, so let's say,
yes,
can I
like
say 2.3?
yes, so maybe 2.35 or
Okay, so if it is lower, that means it is sweeter, or it should be higher for it to be sweeter.
so when it's lower, that means it's more like bitter.
Bitter, okay.
Yeah.
Okay, all right. So maybe okay, so let's say this one is orange, so it is sweet. And then the name of the fruit we have over here is orange. So definitely we are getting some insight to how we can model this. Okay, and these are discussions that we are definitely going to have with the food scientists, the food process engineer, and those people who are experts in that field. So once you have this, then you ask yourself, okay, what are, and let's say we are dealing with let's say 4 different kinds of fruits. So we are dealing with orange, we are dealing with mango, and then we are dealing with pineapple. So we have orange, mango, pineapple, and then we are dealing with let me say pear. So assuming we are politically correct, there's no problem. Definitely the bricks, okay, as we've come to learn about the sweetness of a particular fruit. Definitely the bricks we have in orange is not going to be as the same as we have in pear. Normally pear is not as sweet as oranges, but then we can actually look at this from, okay, somebody says, please, I've never seen a red orange. Okay, so this one too, maybe, let's say like yellow or something. Yes. Yeah, so yellow or even the color orange in there and stuff like that. But then you can imagine how even this one are fruits that we've seen before, and how difficult it is for us to conclude on certain things. So imagine something we haven't seen, and the biomedical people, in fact, some of the things you've even heard of them, you've heard of maybe ECG scan, you had maybe some breast cancer data and some things in there. The material people, you have some parameters that you use. We haven't seen them physically. So you can imagine how complicated some of these things are. So you definitely need somebody who is more of an expert to guide you through. So I'm going to cut down on the talking and move straight to action. So we are going to settle on these fruits. Okay, so for orange, mango, pineapple, and pear. And then we are going to settle on a few of these features, okay, because we cannot do all, but then the concept is once we're able to know how we go about this, we can also model things. If we want about 100 features, we can look at them as well. So we are going to settle on this sugar content because at least we are going to have some numbers. That's going to be very easy for us. We're also going to settle on the acidity. We are going to have numbers. That's also going to be very easy for us. So once again, you should be thinking about, okay, if you are thinking about numbers, which are going to be floating point numbers, then you should be thinking about not the round ends, but then the uniform. Then for the texture, we can look at texture. And for the texture, let's look at, let's say, orange is going to be smooth. Mango is going to be smooth, okay. Pineapple is going to be spiky. So let's say we have spiky over here. If we had, we are getting too smooth over here, no problem. But then if you had, okay, so now let's make orange rough because orange is not that smooth as compared to mango. So let's say orange is rough, mango is smooth, this one is spiky, and then pear. The pear, no, I think the pear should be rough as well. If orange is rough.
Don't answer yourself. Let them also contribute, please.
Okay. So what do we make of orange? Is it going to be rough or smooth?
Yes, sir. Please, I think it should be rough.
It should be rough. Okay. So please, do you agree with him? My brother says it's rough. Okay, so now we are getting some insights over here. Okay, somebody has responded yes over here. Now let's look at, for instance, the color. I still want to go with color, okay? And I just want to, the size and the weight, I think it is either going to be small, large, or whatever. I want something that's quite interesting. So now, let's get rid of this size for now. Okay. So we are getting rid of size for now. So we have the color yellow. We have the weight over here as maybe 1.5, whatever metric that we are measuring. Now the shape is oval. This one is this and stuff like that. Okay. So now everything looks good from my point of view. So now let's look at mango. Mango can be either green, yellow. Okay, so mango, for the choices that we have over here, we can either look at it as yellow or green. And I think orange can also be green as well. So orange can be green. So these are the ones that we have over here. And for pear, you agree with me that pear can be green and then it can be brown, because I've seen some pears that look brown. And we can go on and on. But then at least we have a sense of whatever thing we are doing. So now let's actually write the function to actually create this data. So we are going to write a function. So definitely we use the def keyword, and I'm going to say generate underscore data. Now I'm going to go step by step. And the first one that we are going to do is we are going to generate data that we are going to save in an NumPy array. And then we are going to look at another one that we are going to save in a CSV file format. So like we can now import and do the things that we saw do. You saw me do. Now, what I want to do is, okay, I'm thinking about it in a sense that, okay, if I call this generate data function, it's supposed to generate data, but then I want to pass in a parameter over here. That's going to be like the size. So for instance, the number of instances I want. So I'm going to have, let's say, 20. So I pass in 20 over here when I call this function. If I want 100, I pass in 100 over. So this one is looking good. And the question or the next thing I want to have is, okay, I want to have the fruit list. So I'm going to have fruit underscore list. And the fruit list is going to be the list I've decided on. So I want to do a classification for mango, orange, pineapple, and pear. So these are the ones I'm going to specify over here. So I'm going to have mango. I'm going to have orange. I'm going to have pineapple. And then I'm going to have pear. So there's a list that I want these values to be randomly generated, and then these are going to be, for instance, the classes that I have in there, or the categories. So now that I have this, now I want to do some looping over here. Okay, I want to do some looping over here. So now I want to loop through the number of size, because the whole point is, if I want 20 fruits generated for me, then I want to loop through, or I want to have a loop that loops through things 20 times. So what I can do is I can say for, and I'm going to just do this, okay, underscore in, and I'm going to say range, and I'm going to say size. Now I'm just going to say print, and there's a variable, okay, this underscore you see over here is a variable. So when I do this, and then, for instance, let me call this generate, data, and if I'm to pass in, let's say 20, okay, I'm just going to loop through this 20 times, and that's what we see over here. So it is starting from 0, as you see over here, and then looping through to the index 19, but then you count and you get 20. So that looks good. Now, one of the important things I want to mention is, okay, so now once we are looping, I want to be randomly creating the fruit. So for instance, look at this. If I do, for instance, based on this, I say fruit is going to be equal to, and I say, okay, let me import random over here because we want to deal with random. So I'm going to say, sorry, I'm going to say import random, because we want to work with random. So now I can say the fruit is going to be equal to random dot, remember we spoke about choices and choice, okay? So when I say random dot choice and I pass in the fruit list, all I'm trying to say is, okay, for everything that you be looping through, and for instance, if I say I want to print out fruits, and let me just do return fruit over here. So this is what I have, okay, a very simple one. We know that the random dot choice is just going to go through this list and randomly select one of the fruits over here. And I'm saving it in a variable called fruits. And I'm saying that loop through this, the number of size times, which is 20 times, and randomly select from this list some fruits for me. And instead of just now printing 1, 2, 3, 4, 5, whatever, I now want to return the fruits, okay? So now when I run this, okay, because I'm returning, I then have to print this out. So now let me just do, let's say data is equal to this. And now let me just do a printing of data so that everything looks very simple. So when I run this, we get mango over here. And that's because of what we have. So let me take the indentation inside. We have pineapple, okay. This is because of something, but then let me just do a printing of this. We'll come back to the return. And because we are printing, okay. So now this is what we should do. So now, yes, it is doing the, how do you call it? The looping, but then we are not doing things right. And what I want to do is, let's have a variable called data, and this data is going to be an empty list. So now the point is, okay, when you randomly select based on the choice from this fruit list, and you save it in fruits. Now I want you to append or put it in this data or this empty list over here. Okay, so I think that's what we're missing out over here. So now I'm going to do this data, which is the empty list dot append. And because this is a list, we can have the append method. And what do I want to append? I want to append by the fruits that I've selected over here from this fruit list using the random.choice method. Okay, so now that I have this, if I'm to do a return of the data, initially it is an empty list, but then because of the appending that has been done, it is now going to be populated. So now if I'm to do a size of 20 and then save it in data and also print it out, when I run this, we get this list showing up over here. And these are just random selections that have been done, randomly selected. So we have orange, mango, orange, pear, pineapple, blah, blah, blah. But then this is not the only feature that we are talking about, because we have quite a number of features. So the other features that we spoke about or we have settled on is, for instance, the color. So once again, we can also specify a color over here. So I'm going to say color list is going to be equal to what I have. And the colors that we want is, let's say we want, let's use orange over here. Let's use yellow. Let's use green. And let's use brown. And then please, which other one else can we use for the colors of the fruits? Mango, pineapple. Okay, I think these are the ones that we can think of. Okay, but then there are different shades of colors that we can also consider. Now let's look at, so we are going to look at the color. Now let's look at the weight. The weight is going to be a floating point number. So I can quickly come in here. We are going to talk about the color later. I can quickly come in here and I'm going to say that the weight is going to be equal to random dot, remember the uniform. And what do I want to get? I want to get a floating point value between a specific range. And this is where we cannot just put up arbitrary values. If we spoke to the expert, he said, oh, for whatever, for instance, fruit there is going to be, let's say, between this and this. So now we are just going to look at it from doing it, I mean, just raw like that. And we are going to put in some checks to make sure that if it is mango is not going to exceed a particular weight, okay, because pineapple can definitely be heavier than, let's say, mango. So we can put all those checks over there. But then for now, let's just look at we just writing it as it is. So let's say we start from, let's say, a 0.5, and then we are ending with a 5.1. So this is going to be the random uniform from this range that's going to be saved in weight. And remember, this is a list, so I can still do the append over here. But then what I want to do is I now want to typecast this as a list, because I cannot append and do more over here. But then when I do this, I can now pass in, for instance, the weight over here. So now this is a list that I am appending. So everything is going to run. The first one is going to pick up the random fruits, okay, the name based on the choices selection that we have over here. And then the second one is going to pick up some random weights, and it is going to put it up over here, going to append. So now we have just changed a little bit of code over here. But then now when I run this, we get to see something interesting over here. So now let's go back to the top. We get to see that, okay, for mango, the random weight that was selected was this. For pear, the random weight that was selected for this. And this is where, once again, let's pay attention. Unless maybe it is saloon mango, that the weight of a mango can be bigger than the weight of a pear. But then we can have an instance where, for instance, look at this. Pineapple is, let's assume this is a fully matured fruit, okay? Pineapple is, let's say, a 2.5, 2.7. But then we are getting a mango, which is a 4.5. This does not make sense. And these are the things I want to highlight on. That if we just keep on doing random things, it is going to be too random that we have issues moving on, okay? So a better way to go about this is to now put some checks in place, okay? And the checks I want to have is, okay, so I want to put a check in place for instance, weight. And now this is what I want to do. I want to say that if, and this is also going to be from the experts, okay? So if, for instance, the weight that we'll be dealing with, if the weight, okay, is less than or equal to, let's say, 0.9, in terms of what we have over here, I think oranges are going to be the least of weights that we can think of. Maybe oranges and mangoes, okay? So if this is this, then it can either be an orange or a mango. That's the point I want to make over here, okay? Then what I want to do, if the weight is within this, then the fruit should be of a particular fruit. That's the point I'm trying to make over here. So we are saying that if the weight, let me say, yes, if the weight is this, then the fruit, let me do this fruit. So now we are prioritizing, I mean, selecting or giving the weight first, okay? Because the weight is actually going to determine the kind of fruit. So now let's bring the weight up over here. So the weight is randomly generated first. And then if the weight is less than this, then the choices of fruits is not just going to be that fruit all from that list, okay? But we want to be more specific. So the choices of fruit is going to be, now let's put a new list over here. It's either going to be a mango or an orange. So let me put this as a string. So over here, I'm saying that if the weight, or I mean, I've randomly selected the weight over here, but then if the weight that was randomly selected is less than what I have over here, then the fruit that I want to look at should be either a mango or based on the choice that I have over here. So randomly select either mango or orange. Now, what I want to do is, let me say, so let me just else fruit is going to be equal to random dot choices or choice. And this time around, let me just pass in the fruit list. So over here, we have specified something that's going to be very specific. And let me just append it the way as it appears. So let me do weight first, and let me also do fruit second. Okay, so over here, we randomly generate the weight of the fruit. And before we even select the type of fruit, we are saying that if the weight is below this, then make sure that it is picking from these choices and not anything else. Else, just give that some random data. So now let's run this and let's pay close attention to what we see over here. We have, oh, okay, so the first one is, oh, no, that's not what we want.
Yeah. Ken, I think one of the ways we can look at it is first sort out the fruit first. There are different ways you can do this.
Yeah, sure.
Because you could have a situation where a particular fruit has the same weight as the one you are trying to target. So one option is you can sort out the fruit first, and then out of the fruit, then we can now go to the next segment of weight assignment.
Okay.
And then the next one, color assignment, things like that.
Okay.
It makes it much easier.
Easier. So there was even another one that I was thinking we can actually put this in some kind of a dictionary, okay? And the way dictionary works, sometimes it scares students. That's why I wanted to go by this. But then based on,
but even if dictionaries, the way can at least you just explain, but we can also go through the long process.
Okay.
And the long process is we can do first, then we can sort them out. Do the fruit like you did the previous, so you have the fruits now.
Yeah.
Then you can take orange. Then we can now assign weights or we can filter it out because you have showed them filtering now.
Yeah.
You can filter, then take assign different weights, because you can have orange that is 0.8 grams.
Yeah.
You can have a pear that is also the same weight.
Yes.
So we can do the sorting out first by fruit, and then we can now go to the next level of assignment. If the time is up, we can let them try their hands on it.
Okay. All right, sir. So let me just
and let's see. No, the previous years, that's how we do it.
Yeah.
We give it to them. We will do the brief and then let them go and try it. And then when they come, then we also walk them through it.
Yes, sir. Okay, let me just try this and see. I just want to make sure that so let's say I have pear over here. Okay. So let me run this.
And your mango is mongo.
Okay. Mango. Okay. So let me just explain the last points because our time is up, so that hopefully next week when we meet, I'm definitely going to include what Dr. Mil just said. So now the point is, yes, we randomly generate the weight first, and that weight is going to be within this. And this within this is going to be for all the fruits. So we are saying that for all the fruits, the range should be within a 0.5 and a 5.1 for all the fruits. And now we are saying that if the weight is less than what we see over here, then the choice of fruit, you're only limited to mango and orange. Else, you can choose either pineapple. So if the weight is, let's say, a 1 point something, then it can either be a pear or a pineapple. So now let's look at the data that's been generated over here. So over here, we get to see that we have a 1 point something, which is above this range. So it's randomly selected either one of these. And in this case, it selected a pineapple for us. In the second instance, the weight is also 2 points, which is above our range. It selected a pineapple for us. The third instance, it was also above our range, 4 point something. It selected a pineapple. It went on and on and on. This one was also above the range. The first one we have over here selected a pear for us. So everything seemed to be working. Now let's look at an instance where it was actually below the range. So now look at this. We have a 0.6, which is not below that, but then within the range. That's the point I want to make. And it is selecting an orange for us because we have specified that if the weight is less than a 0.9, and indeed 0.63 is less than 0.9. So it randomly selected one of these, which in this instance is the orange as we see over here. Let's see an instance where it selects mango. So we go through this and then mango. I don't see mango here.
Can you please make it to 2 decimal places so that it will make a little bit?
Okay, so
round it up to 2 decimal places. Now, I mean, so that at least we can.
Okay, so let me put out the round method over here. Okay, so let me generate it once again. Okay, so anything above 0.9 is either a pear or pineapple. So this one is good, looking good. This one is looking good. This one is pineapple. And then we get a pear over here because this is just above the 0.9. Okay. Even though it is a 0 point something, but it is above the 0.9. And then we can not see anyone that was below to get a mango and orange. So once again, just by using random, we have to put, things in check. But then let's generate another one and see. And this time around, okay, we get a 0.78, which is giving us an orange because that falls within this particular range that we have specified over here. And then a 0.5 over here, which is giving us a mango. Okay, so this one too is looking good. And then this one is giving us pear because it is definitely above what we have specified over here. And we can go on and on. So please, from now till the next time we meet is a lot of time. So this is what I want you to do. Now look at this, okay? And based on the if else and the other parameters that we have set out over here, I'm going to share this with you. You try as much as you can to complete this, okay? It's just going to be a number of if else, and based on the boundaries that you set for yourself, okay, the upper limit and the lower limit, you can generate some other ones. So for instance, if it is let's say orange. Orange is either going to be yellow or green, and maybe mango is also going to be either yellow and green. So those ones are the selections that will be available to either. So you specify an if statement over here. If color is equal to whatever, okay. So over here you can, for instance, do something like selected color is going to be equal to, then random dots. This one too is going to be a list, so choices. Then you put in the colors over here, okay? So whatever color. Then if the selected color is yellow, then that should be of a particular fruit. You specify that. If that's, so it's just going to be a number of if-else statements that we are going to put up over here. And then next week when we meet, like Dr. Mills rightly said, I'm going to show you a very simple way of making sure that the limits that we set for ourselves is also intact. Okay, so please, any questions? Our time is up.
Yeah, any question, please? Any comments, suggestions, questions? Okay. In the absence of any comment or suggestions, then we'll close for the session today. We would encourage all of you to try your hands on what this is. Just nobody's an exercise that anybody is going to collect. It's just for your own experience. So, Sheriff.
Yes, Doc. Please, I have a question.
Go ahead.
Okay. Please, my question is, the random data that we generate, is it like a model at the back end that is generating it or something?
Okay, so there is an algorithm that you can use to generate random. It's just a simple process, a simple algorithm that we can write. But the most computational, if you call it, whatever, has this. Even Excel has that as well. All those computational, numerical computational tools, they all have this number generating capacity. So this thing is linked to your clock, your CPU clock. So that is why anytime you generate, the number changes. So it's just an algorithm that is written in the any numerical computational program that allows people to generate numbers. Is it, have I explained it enough for you, or still further clarification?
Yes, if I will get further clarification.
What is it? So, okay, so let's say, for example, we want to have student ages on this, like the University of Ghana. We want to develop a machine learning model that can do assignment of students, maybe into levels based on their age, or even assign students into programs based on their age. So now, age is a little bit weird. It's for selection of program. Let's say grades. So in the grading scheme, we have numbers, SS level, we have numbers. We use 6 subjects.
Yeah,
we use 6 subjects. So the
Yeah.
6 subjects, the minimum we can have is 6. And the maximum the university can take is 24. Right. And then the university also has another aggregate that they also take for other group category of students. So let's say 36. So now, these numbers, if we want to generate artificial students that we don't have their grade, if we don't, one option is we'll wait for West Africa to give us the names of students or index numbers, names, and then their corresponding aggregates. We can use them. That is what we call real data. But we can also decide to do something on our own, and we can say, let's create artificial index numbers. we know the index numbers. The length of the index number, is it about 6 or 7? The WASI numbers. Is it 6 or 7? Can somebody?
They are 10.
They are 10. Okay. So 10 digits. So that 10 digits, we want to create, let's say, 50,000 students who are applying to the university. So we want to create 10 digits. Naturally, 10 digits, since we don't have the actual number from actual information from West Africa, we can say, okay, let's allow the machine to generate for us. But in generating for us, we know that the West Africa, every year, they have a certain code. Let's say the first 2 or 3 codes represent a year. So we can say, okay, 2024, the code is, let's say, 108. So we can plug 108, and then we say, the computer, give me all numbers. So it can generate 108 is fixed, and it can generate somebody's number will be 0001, as long as you can get 10 digits. So this is what we ask the computer to do. So there's a algorithm that has been written that is, okay, generate numbers for me. Then it can generate the student index number. That has nothing to do with your model. You are trying to get the data to help you do your model. Please, are we okay on this?
Yes, okay. Thank you.
Oh, you want some further clarification?
I think it's okay now.
So because you can use this number, for example, it can be 2 raised to the power x number plus some factorial. It's just a simple code. And you can also check, if you have the time, just check on the Google platform, maybe random number generation code, and it can show you some of these simple codes. If we were in the classroom, this is something that I can show students generate easily. Just generate. But you don't want, in number generation, you don't want one number to be the two students will have the same number. So we have a number generator that will help you to generate number uniquely without any repetition. If there is repetition, you're going to have conflicts. In that case, then this is where then what Ken told us last day, that is the duplicate. So we have to remove the duplicates from the data set. Maybe what I can do is next week, I will just show you something briefly on that, if that will work better.
Yes, I would be very glad.
Okay. Please, are there any other comments, suggestions? Okay. If there are no further questions, suggestions, then we close for the day. We meet, God willing, we meet next week, Tuesday. Now, I'm counting the days. We have, next week, we have about 2 more or 3 weeks to go, because we will end at the end of this month, because you'll be coming to school. So we'll end at this month and then allow you to maybe to find time to prepare yourself for school. And when you come to school, then we continue from there. Okay, so have a good weekend to everybody.
Thank you so much, Doc.
Thank you very much, sir.
Okay,
Thank you
welcome.
so much.